Hey guys, this is Remy. Welcome to another video. It's been a long time. In a previous video of mine, I've shown you how to run an Ethereum node and I've explained more or less what that node was for and how to use it. So in this video, I've decided to show you how to actually use that node, how to connect to it from your local machine or from the front end or from your server as you will, and actually query the Ethereum blockchain or the node that you're running using some queries to source information. For example, you could have a token, a coin, an ERC20 token, and you might want to get some information about this token directly from the blockchain, such as the token name, the token symbol, token supply, the total supply of the token, and of course the token price. Now all of this info can be sourced directly from Ethereum, and if you're running the node on your local machine, you already have all of that data. So it's just a question of querying it and indexing the data properly in order to be able to get the data out of the blockchain. And in this video, I'm going to show you how to do it using an NPM package called web3js. So let's get straight to it. All right, let's get started. So first, what we're going to do is we're going to make a quick directory for our project. Let's call it Token Explorer. And then we're going to cd into that. And in here, we're going to initialize an empty node project. Now, the way I like to do it is I like to use the Google standard that gives you TypeScript right out of the box. So I just go npx, and then GTS, which stands for Google TypeScript Standard, and then you just type init. And this basically gives you everything you need to get started with Node. When I ask you if you want to generate a package.json, just say yes, and then it gives you everything, including TypeScript. And then you can just start working with it straight out of the box without needing to create your own TS config, your own package.json, your own any of that stuff, and without needing to npm install all of those extra libraries and node modules. All right, so it's done. Let's quickly have a look. And we have, as you can see, ls.src, we have all of those things, including index.ts. So let's go ahead and open it in VS Code. Here's our VS Code. Let us check. So we have index.ts, and normally I just go ahead and delete all of this rubbish and I just go ahead and do console.log and then type something stupid like hello world, just to make sure that everything's installed correctly and it actually works. So then I go ahead and go node src/index.ts. all right, hello world, it works. Cool. So now next steps. Let us connect to Alchemy and then get connect to a node, to an Ethereum node there via Alchemy, and then get the current block number just to make sure that our node is working and connected. So the way we do that is we just go to Alchemy. Let's go ahead and go Alchemy, and okay, not this Alchemy, not medieval type of Alchemy, Alchemy crypto. Cool. Alchemy.com. Just go ahead and log in. Hopefully I'm already logged in. Yes, I am. And then just go ahead and click on create app, and here give it a name. So it's got Token Explorer temporary, right? And then in the description, just type something fancy like fancy. And then it's development, Ethereum in mainnet, and go ahead and do create app. And then where is it? Token Explorer temp here. Just go ahead and click on that, click view details, and then click view key. Now here is your API key. It is the last bit here. So just go ahead and copy the whole URL, the whole URI. Let's go back to VS Code and let's create a variable called const URI, and that equal to what we've just copied from Alchemy. So this value. And then of course we don't actually want the API. So let's go ahead and do const API key. So let's just keep it separate. And that is going to be equal to this little value right here. Let's control exit. Control X, Control V. Let's go ahead and type that here. That's done. And in here, instead of having these braces, we're gonna have these little back braces that allow us to type values into our string. And so that goes like that. And just go API key. And they should virtually be the same thing. So now our URI does connect to Alchemy. Now, how do we actually connect to Alchemy having this API key? So let's have a look. I don't have it off the top of my head, so let's go ahead and Google it. Connect to Alchemy. Nodejs. getting started. That sounds like a pretty good page. Okay, scroll down here. Setup. So we need to install a couple of things. What we'll need to install is Alchemy. Hit this one. Here, npm install Alchemy Web3. So let's copy that and paste it into our terminal. Yep. Let's wait for that to install, and while that is installing, let's see. Okay, cool. So we have so basically const alchemy is requiring this, and then we have Web3, and that's your API key, and then we get the block number like that. So let's go ahead and copy these 2 lines right here. Is that installed yet? Yeah, almost. So as soon as that is installed, we're going to paste this here. Let's do it now. Let's put it on the top of the file. Actually, we don't need that on top of the file. Let's put it on the bottom of the file. Cool. Cool. We have Alchemy and we have Web3, and this one needs to be URI because we already defined URI. So we're just gonna go ahead and do URI instead of that whole URL thingy. So now we have Web3. And now what can we do with Web3? Is that installed yet? Yes, it is. So now let us test it out. So let's go ahead and do a let block number. Let's find the latest block number on the Ethereum blockchain. And this will equal to await. By the way, it's not gonna work because we need to create a function. So go ahead and create a function called get block number. And it's gonna be an async function. And in here, what we're gonna do is we're gonna get let block number, and that will equal to await. Now we can do await. Web3 dot eth dot block number, and then we're just gonna return block number, and we are just simply going to do this. Let's go const main is equal to async, and in here we're just gonna go await block number, let block number is equal to await, and we're gonna await the function that we just created, get block number, and then we are going to simply console.log block number. Okay, cool. And then we're gonna call the main function, and let's check it out. Let's see if it works. Okay, node src/index.ts. Cool. That's not a function. Block number. Okay, block number is not a function, isn't it? What was it called again? Let's check. I'll get block number. It's not block number, it's get block number. Cool. Cool. Let us quickly fix that. Get block number. Okay, let's check it out. See if it makes any difference at all. Just click up. All right, there we are. The latest block number is 13,304,868. Cool. So now that this works, that's our first function. Let's define all of the other functions we're gonna be using that we're gonna create. Let's see. What can we get for a token scanner? Let's get a token name, for example. So const get token name. All of them are gonna be async because all of them are gonna be awaiting something from the Alchemy and from the node. Okay, so that's token name. Let's get token symbol as well. Token symbol. And we're going to then be completing these functions one by one. Okay, that's token symbol. And let's get total supply of a particular token. By the way, these tokens, these functions, they actually do take an argument, token address, and it's of type string. And all of them do, so they should have taken that as well. So it's going to be address of type string. and likewise for here of type string. Cool. So there we go, total supply. Then we can also get the price. So const get price of a particular token, which is by far the most interesting function. Get price in ETH and async. It takes an address. And let's get price in USD. Takes address as an argument. Cool. Those are going to be our functions that we're going to be implementing, so let's get them done real quick. So first of all, we need an address of a token. So let's get the token name. Token name would be as simple as basically we'll need a contract. So the contract of the tokens. So in order to define the contract, we'll need two arguments. So we just say let token contract, and that would equal to new web3 dot contract, and this takes two arguments. This takes the ABI of a token, so let's go ahead and call token ABI, and this takes the token address. So obviously we don't have either of them at the moment, so let's go ahead and define them. So token address will just be address that we've passed as a parameter in the beginning, so this is going to be address, but we don't have token ABI. So what's token ABI? Token ABI is basically like the template of a smart contract that defines the specific ERC20 token. And since ERC20 is a standard, then most of the tokens, if not all of them, have a very similar, if not the same ABI. So if we take one ABI from one of them, that will pretty much cater for all of the tokens for our needs. So let's go ahead and go to Etherscan and then find a random token. For example, what should we find? Let's do link, chain link. Okay, here's the contract for chain link token called link. And to find our ABI, we just go contract and scroll down, and here it is, contract ABI. So go ahead and copy this to clipboard like that. And then back in our VS Code, we'll just create a new file. So let's create a new file called token ABI.json. Okay, cool. Here we are. And just paste all of that, all of which we've just copied into here. Right there, good. And now here, let us find, so first of all, we'll need, what is this mess? We'll need to read a file, we need to read the JSON file. So to do that, we'll just const fs equal require, I believe that was the syntax, fs, that's for reading files, right? And then we'll just read the file right here. Okay, so let or const token ABI is equal to fs dot read file sync, I believe. Yes, read file sync. And what are we reading? We are reading token ABI.json. So let's go ahead and provide it. Token ABI.json. And all of this needs to be parsed into the string array. So at the moment it's a JSON format. We'll need to parse it into a so JSON.parse. We'll need to parse it into an array of strings. There we go. And this gives us our token ABI. So now token contract is a new contract with this particular ABI and this particular address that we're gonna provide later. So let's keep the Etherscan page open for the address, which is, by the way, right here. This is the address of the contract. So once we have the contract, we'll just go let token name, and that equals to await, and we'll token contract dot methods. It has specific methods, and those methods are actually defined in the ABI. So if you have a look through it, you can see that it has some particular methods. Like for example, it has, here's our inputs, name, and outputs is a name and is of type string. That's cool. So when we do this, we go back to index and we go ahead. What methods do we have? We have a method called name, as specified right here. It's called name. So we'll just go name, and then we just call that particular method. And then we just return token name, right? And that is all we would need to do for our first method, which gets the token name. So let's go ahead and try it out. Let's go back to Etherscan and copy this address of the link token. Let's go back to let's go to our main method, and let's quickly get rid of this and just go ahead and type console.log, and then we'll just await get token name, and this takes an argument of the address. So let's go ahead and make a variable let address link equals that what we've just copied from Etherscan, and this will take address link as an argument. Cool. Let's go ahead and run it and see if it works. Node src/index.ts. Okay, syntax error. Address string, get token name, is something missing. Token name takes one argument, is a string. This is a string, and so let's go ahead and do, what was the error again? Okay, syntax error. So get token name async address string, which equals to, okay, there's a missing so it's an async, and obviously it takes an argument, and then it takes that. I'm not sure what's missing. Let's for a second not call this function and run the program again and see if it complains. Node src/index.ts. Yeah, it still complains. And so obviously get block number worked, but so const get token name equals async, exactly the same. We have the brackets, then we have the arrow, and then we have this. So I'm not sure why it's complaining. Let's get rid of let's for a second get rid of that and comment all of this. Save and run this again. Even though I've saved it, it still complains. Oh no, that's a different one now. That's a right. It's just complaining about token symbol, but for some reason, because it gets an argument. Right. So let me just experiment with something. Before I do this, before I start debugging this further, I'm gonna show you a quick little trick. Instead of using Node, because maybe this would be the problem that I'm using Node to compile the code, we'll use something called TS Node to compile our code, which is TypeScript Node. And the way we do that, basically, what we want to do is we want to type the following. So first of all, we want to install them. So npm install, and we just install two things. One called nodemon, and nodemon is basically something that will continue running your program on repeat and wait for code changes. So you don't have to type this again and run it. Once you've run it once, you're just gonna keep running until you change something. So nodemon, and the other thing it's gonna install is ts node. So let's install these two things. Click enter. Let's wait for that to install, and then we'll try running this program another way. Instead of using Node, we're gonna run it using TS Node and see if the problem persists. Okay, cool. So now what we're gonna do is we're gonna do npx ts node, and then we're gonna run src/index.ts. Yeah, in this case, it didn't crash and everything was fine. So let's uncomment this and run it again. Okay, still crashed, but the error is different now. Okay, web contract is not a constructor. I might not be creating the contract the right way. Web3, is it .eth? I think it's .eth, it's what I'm missing. Let's try that again. Yeah, that's right. And now we actually got the name of the token. As you can see, it's called a Chainlink token. So the problem was that I was trying to compile this code, which is ES6 notation and TypeScript to boot. I was trying to compile it using the simple Nodejs compiler, and it didn't work. You needed to use TS Node to compile TypeScript, where it takes arguments such as for example types. For example, it takes an argument that is address of type string, and not only compiles JavaScript, it doesn't really compile TypeScript. So once you start typing the actual TypeScript notation thingies, Node is not gonna cut it, so you need TS Node. And so let me show you how to do another thing with nodemon, because we also installed nodemon. So we're gonna do nodemon --exec. Then what we execute in TS Node, then --files, and then src /index.ts. So that's a command, and my bad, it's not node, it's nodemon. Nodemon command not found. Interesting. Didn't I install it? npm install. Okay, cool. Maybe global. Yeah, it seems to be taking a little more time, so maybe this is what we needed to do. Okay. Yeah, there we go. That actually works. You need it to be global. So what we do is nodemon. What we do is nodemon --execute ts node --files, and then src /index.ts. There we go. So now what this does is it's gonna execute our program, and it's just gonna keep on running it, and you see clean exit waiting for changes. And once we change something here, it's just gonna run it again automatically. So you don't need to go ahead and type all of that to run it again. For example, if you change hello world, yay, and we're just gonna save this file. As you can see, it's just restarted on its own. It's running it, and it ran through the whole code again. Okay, so to save us typing all of this stuff right here, every time we're gonna reinitiate our terminal, we can just go to package.json, and in the scripts section, so here's the scripts. So let's go ahead and add a few. So nodemon is normally used for development purposes, so let's go ahead and go dev, and here we're gonna type this command. So what's that command? It's gonna be nodemon and --exec ts node --files src /index.ts. And the other one, where we just execute it once and not again, is gonna be with the ts node, is gonna be, let's call it start. And this one is gonna be npx ts node src /index.ts. Cool. So now let's try. So now in order to run this, we're just gonna do, what we're gonna do is we're gonna go npm run dev, and it's gonna run the nodemon version of our code. So as you can see, it did exactly the same thing as we did before. Instead of typing all of this again, all we had to do is just type npm run dev, because dev is the command, is the label for this entire command that we just unnamed it in package.json. Okay, let's digress. Back to the important stuff. Let's stop running this for a second. Let's go back here, and so our token name is done. So let's get token symbol. As you can imagine, it'd be almost exactly the same thing. So let's get so we'll need these two lines again. So let's go ahead and get them again. Token ABI and token contract. Then we go let token symbol, and it's gonna be await token contract dot methods dot symbol dot call, and we're just gonna return token symbol. So let's run it to make sure it works. Cool. So instead of running get token name, we're gonna get token symbol, like that, of the same token, so chain link. Let's go ahead and run it. npm run dev. There we go, link, so it gets it. Now let's get total supply. Again, exactly the same thing, very simple, just copy the first two lines because we'll need that contract. and then let total supply, and that would equal to wait token contract dot methods dot total supply. I'm just gonna call that. Yep, let's just quickly return it and make sure it actually works by changing this. Instead of token, we just go total supply. Let us check. Yep, there we go. For Chainlink, it's some big number, probably quadrillion, a little bit more than quadrillion, but anyway, this is the number of total supply of Chainlink. Now let's get onto the interesting stuff. Price. Now, how do we get the price? Obviously not using any APIs like CoinGecko, CoinMarketCap, but actually get the price straight from the blockchain in a decentralized manner. Okay, cool. So the way we can get the price is from Uniswap. And how do we get the price from Uniswap? So Uniswap has something called liquidity pools. I'm just gonna write it here. Liquidity. I hope I spelled that right. No, I didn't. Anyway, liquidity pools. What a liquidity pool has is a token pair. So when you create your token for the first time, if you want to trade it, so you're not gonna put it on a big exchange like Coinbase or Binance or anything, because obviously you're not gonna list your token unless your token is already famous. So in order to trade your token, what you do is you put it on a decentralized exchange DEX, such as Uniswap. And Uniswap has pools, and those pools consist of pairs of tokens. For example, if you were to create something like create token A, and then you're gonna put it on Uniswap as a pair against another token like Ether. So you're gonna put say 100 of your newly created tokens, and you're gonna put into that same pool say 2 Ether, right? So what does this mean? That means that what you're telling the market is that 100 tokens and 2 Ether means you can buy for 1 Ether you can buy 50 of your tokens. So for 1 Ether you can buy 50 of your tokens. So for 2 Ether you can buy all of the 100 of them. So in order to get the price of your token, it's basically gonna be 100 divided by 2, and it's gonna be 50. And 50 is gonna be how many tokens you need to buy 1 Ether. And then if you wanna get the price in Ether for that same token, it's just gonna be 1 divided by 50, which is gonna be 0.5. And 0.5 is gonna be how much Ether you will need in order to buy. Wait, not 0.5, 0. Well, in any case, 1 over 50 is gonna be how much Ether you will need in order to buy one of your tokens. I think it's gonna be 0.05. 0.05. So in order to calculate the price, we just need to find a pool on Uniswap, and what we need to do is we need to get the balance of the token that we're interested in, the balance of the pair token, which is normally Ether, because we're looking for that particular pool where it's a pair with Ether. And then we're just gonna do this little formula right here, and we'll get the price that way. So let's go ahead and do that. So first I'm gonna show you how to do it for Uniswap version 2. So Uniswap V2 has this particular formula, and we're gonna do it exactly this way. Uniswap V3 is a little bit different, and the reason Uniswap V3 is different is because there isn't just one pool for a particular pair. There are many pools. I think there are 3 pools, and each of them has a different commission that you pay to liquidity providers every time you make a swap. They are just different categories, like 0.3% or 0.5% or 1%. So since there are different pools for one particular token, you have to get all 3 of them and get an aggregate of the balance of each of those pools in order to get an accurate estimation of the price. But we're not gonna, but Uniswap V3 has a different way of doing it to prevent you from just having to search for all of those different pools. And I'll show you how to do that. But first I'll show you how to do it with Uniswap V2 because it's more straightforward. So first what we need to do here is we'll need to define a pool, right? So we have an address of a token, and we need address of the other token that we want in the pool. And in our case, we want Ether or wrapped Ether, because Ether itself doesn't go into a pool. So they wrap it and they call it wrapped Ether or a symbol. So we need the VETH address. So let's go ahead and go say let address VETH. And that's what we're gonna need. and this is equal to, let's go to etherscan and just type Veth, and here it is, and just copy that address right here. Wrapped ether, right? Yep. Let's go ahead and copy that address right here. So we have the address of our token, and we have the address of the other token that we want within the pair in a liquidity pool, which is address Veth. So now let's go ahead and get the pool. How do we get the pool? Uniswap has something called the Uniswap factory, and from that factory contract, it actually has a method which you can call in order to get a specific pool that you're interested in. So let's go ahead and define Uniswap factory. So I'm just gonna make a space, let Uniswap V2 factory, and it's gonna be the contract. And this equals to, and as you know, web3.eth.contract, and it will take two arguments. It'll take the Uniswap V2 factory API, which we don't have yet, and it will take the Uniswap V2 factory address, which we don't have it yet either. So let's source these two variables. Okay, let's go to Google and let's find the API, Uniswap V2 factory API. There we are, from the Uniswap's official page. Here's the address on the Ethereum blockchain where the Uniswap V2 factory is deployed. So let's go to etherscan, paste this address right here, and here it is, Uniswap V2 factory contract. Let's go contract, and let's find their API. Here it is. Just go ahead and copy that as we did with the token API, and simply create a file called Uniswap V2 factory API.json. There we are. Just go ahead and paste all of the stuff into here, and then we're just gonna define it right here, right? I will need the we'll need that. So let's just copy this line right here and paste it into here. And instead of calling it token API, we'll just call it Uniswap V2 factory API. And then instead of reading token API.json, we're gonna read the other one. We're gonna read Uniswap V2 factory API. V2 factory API, and let me spell that, Uniswap V2 factory API.json. And then we need the address, right? So let Uniswap V2 factory address, and it's gonna equal to the address of the factory, which is right here. So let's go ahead and paste that. There we go. So now we have Uniswap V2 factory, yes. Now what we need to do is we need to get the pool. So how do we get the pool? Simple. So let Uniswap, pool, and this will equal to await. Now we have Uniswap V2 factory, so Uniswap V2 factory dot methods dot, and the method is called get pair, and this takes two arguments. It takes the first token that we interested in, so address, and it takes the second argument is the other token, and in our case it's address wrapped ether or address Veth. I'm gonna ahead and okay, cool. At this point I'm just gonna wanna make sure that everything that I've typed so far actually works, so I'm gonna console.log the pool just to make sure that it gets us a valid address of a pool between these two tokens. So let's go ahead and run it. So get price ETH. Let's run get price ETH. Not console.log because it doesn't return anything, just await get price ETH, and we'll pass it the address link. Cool. Let's go ahead and run it. It crashes. Okay, good. I mean, not good, but we'll see why. Please use, oh yeah, I forgot to use the new to initialize the contract, didn't I? Where is it? New web3 contract. Wait, what? Where? line 50. Let pool equals await Uniswap that methods that get pair. Oh, dot call. Cool. And what else was wrong with it? Please use the new word to initialize web3 contract object at ether. On line 50, apparently I'm not initializing the contract, but it. Okay, so line 50. There's something wrong with line 50. Uniswap V2 factory dot await. Cool. Let me just go ahead and comment this out. This whole line. And this as well. And run it just to make sure that nothing is wrong this time around, because I'm pretty sure that the error is not there. Yeah, as I thought. Oh, index.js, right, it's somewhere within the Node modules, like I said, reading these errors. Okay, so basically somewhere within my program, I'm trying to initialize it contract, and I'm not using the new keyword, but it's not telling me where. So I'm just gonna have to scour this for myself. Oh yeah, there we go, 65, right? But that's just main. Yeah, it's not really helpful, but let's just find it. So basically on price ETH, I have the address, I have Uniswap V3 factory, and then I have the, oh yeah, right here, of course, could have just looked. So anyway, there we go, new, and this should solve the error. So let's go ahead. Yeah, there we go, cool. Solve the error, and there is our address, the address of the pool. So let's go to Etherscan and let's have a look. And as we can see, that this is indeed a pool, and it's a Uniswap pool, and it has two tokens here. It has wrapped ether and it has link within it. Cool. So now that we have the pool, what we can do is we can get the balance of each of those values. So for our purposes, we need the balance of wrapped ether, which is 9,423, and we need the balance of the Chainlink token, which is 1 million and something. So let's go ahead and get the balances of those two tokens. So let's go get rid of the console.log, and so next thing we need is the balances. So in order to get the balance, we'll need the contract of both of the tokens. So let's define the contract. So let contract token, and that will equal to new web3.eth.contract, and this will take token ABI. And what's next? It will take the address of Chainlink, in this case just address, because we provide it as an argument. So token ABI is basically this. We'll just go ahead and copy this line and paste it in there. Cool. And then we'll need the address of the other token as well, so of the wrapped ether. So the contract of the wrapped ether. So contract path, and it's equals to new web3.eth.contract token API, and the address of wrapped ether, address path. Okay, so now that we have the contracts for both of them, they have a method called balance of, and we'll find the balance of these tokens that is contained within the pool. And the way we do that is as follows. So let balance token, and just simply so contract token dot methods dot balance of, and balance of what? Of the pool. So we go pool, and that should give us the balance. Of course, this is a weight, and let's get the balance of wrapped ether again as well. So let balance path equal to weight, and in this case contract path dot methods dot balance of, and we'll just go pool. So just to make sure that it works, let's just console.log both of these values. Balance token and balance path. Cool. Okay, just prints a function. That's because I didn't call it, right? So dot call. Never forget to include dot call in here. Okay, cool. Let's see. There we go. We have these two values now, but they're not exactly right now, are they? Because as you can see, where's the terminal? It has 9,423 ether, but in this case, in our case, it says 9,427. Well, pretty much the same, but the problem is with the decimals. It has a lot more decimals, and as you can see, that's pretty much right. But then it has a lot more digits, not decimals, than a lot more digits than the original value. And this is because it evaluates these values at the lowest possible denomination. So each token has a denomination. In the case of Ethereum, in the case of Ether, it has 18 denominations, and the lowest of them is called Way. And in the case of other tokens, they might have their own types of denominations. So let's check what Chainlink's denomination is. So let's go back to Etherscan. Let's type Chainlink, and let's check the token. And as you can see, the decimal point, the denominations of Chainlink, which is defined as decimals, is 18. So in our case, it's the same as Ether, 18. So how do we get decimal? Because basically what we'll need to do is we'll need to divide. In order to get our balance correctly, we'll just need to divide it by 10 to the power of that decimal. So balance token would actually equal to balance token divided by, and it's just going to be divided by 10 to the power of the 10 to the power of the token decimal, right? And the way we do that is we go divided by math.pow as we do in JavaScript, and then go ahead and say 10 and token decimal. Now, how do we get the token decimal? Simple. We just go ahead and do let token decimal equal to token contract, not token class, token contract. Oh no, contract token, my bad. I think that imported some rubbish up top. Just gonna delete it. Auto imports, right? Cool. Where were we? Token contract token dot methods dot decimals dot call, and of course it will be await. And for the wet decimal, we can do the same thing, but we already know that it's 18. So in order to save us some time doing the await function, we'll just say 18, because we know that wrapped ether is 18, and it's always wrapped ether, so it's gonna be 18. So balance token is gonna be that divided by 10 to the power 18, 10 to the power of token decimal, and balance veth is gonna be also balance veth divided by 10 to the power of, and 18 in this case, math.power. And then let's print that again and see the difference. See if it's actually more or less correct this time. Okay, it's running, it's doing something, and there we are. So 1,180,809 is the Chainlink, and 9,427 is the wrapped ether. Is that correct? Yes, it's more or less correct. Where the terminal? 9427 and 1181. And actually, I dare say that our values are more correct than the Etherscan's values, because we've just gotten them as real time from the blockchain itself. And Etherscan, I believe, stores them in a database in order to not have to await so much, so that they can display the results instantly, which means that they update it periodically. But more or less it's accurate. So there we go. Now we have these values. We can calculate the price. So what's the price gonna be? The price is gonna be simply price is equal to the balance of the token. So balance token divided by balance wrapped ether. And this value is going to represent how many ether it's going to take to buy one particular token. Oh, yeah, I think that's right. So let's go ahead and print that price, just so we can do it step by step and be very clear about what this means, so that we can arrive at the actual price. So console.price, let's go ahead and run this. Wait for it to compute to get the values, and there we are, 125. So what does this 125 mean? This 125 means it's gonna take 125 link tokens in order to buy one ether. And that sounds about right, because one link token is currently worth $25, which means that it's gonna take about 125 of them to buy one ether for $3,156. So now that we have this value, in order to flip it on its head and see how many ether it's gonna take to buy one link, which is the real value we want, is just gonna be 1 divided by this number. So let's go ahead and print the value again, and it's gonna be how many ether is it gonna take to buy one link? 0.007. Let's copy this number. Let's go to Google, and let's just paste this number into a calculator. Right, so that is a number, and we're just gonna times it by the current price of ether, which was, I believe, $3,156.46. So 56, yeah, 56. That's $25.19, as is, yeah, pretty much almost exactly the same as the actual price of Chainlink as per Etherscan. So now we get the correct price in ETH. This is the end of our function. So let's go ahead and return price. So we would return price like that. And this is for V2, right? So let's just actually rename this method and call it getPriceETH V2. Because we also have a way to get the price from V3. But for now, we're just gonna call it V2. And I'm gonna show you how to get it from V3 in a little bit. But for the time being, let's get price USD. Now the price USD will simply be, so there is a token called USDC, which is called USD coin. And USD coin basically is pegged at 1-to-1 to the US dollar. So in order to get the price in USD, all we need to do is get the price of 1 ETH in USD. So we need to get the following pool that has 2 tokens. Pool, which is equal to, which will have 2 tokens. And the tokens will be, the first one will be wrapped ether, and the first one will be USDC, and the other one will be wrapped ether. So in order to get it, we'll just go ahead and find the price of USDC in ether, and then we'll flip it on its head, and we'll get how much one ether is called in USDC. And flip it on its head, by the way, means just 1 divided by the value. I like to call it flip it on its head. So and then we'll get the price of ether, and we'll be able to simply times this price by the price of ether, and we'll get a $25 in the case of link. So let's go ahead and do that. So first of all, what we'll need to do is we'll need the address of USDC. So let's go ahead and type USDC right here. And as you can see, it has 6 decimals. So to keep that in mind. So we have the address, and we can just go back to our code, and let's start typing it up. So let address USDC that is equal to the following value. Okay, so all we'll need to do is we'll need the price of USDC in ether, right? So simply let's go ahead let's call price ETH, and we'll just go ahead and we'll say await, and we'll just call this method right here that we already have, get price ETH V2, and we'll paste address USDC as the value, as the address that we want. So let's go ahead and console.log this to make sure that it works. Price ETH. Okay, here instead of calling this, we're just gonna call USD of address link. Actually not of address, but it doesn't matter at this point. it's just gonna print us the address USDC in any case. So let's go ahead and let's run this. And the value that it's gonna give us is 0.0003, and that is how many Ether it's gonna take to buy 1 USDC. So let's flip it on its head. Let's instead of let's go ahead and say price ETH is equal to 1 over price ETH. Okay, let's print this next value, and that should give us 3,156, I believe. 3,154, good enough. So this is the price of ETH that we've just gotten directly from the blockchain, from Uniswap. And all we'll need to do now is basically price of this is the price of ETH, and now price of token, let price token, we'll just go await get price ETH V2, which is our function's name, and in this case we're getting it of the address, right? And in our case will be Chainlink. And then what we're gonna do is we're simply going to say let's do it after here. Let price is equal to price token times price ETH, right? And we're just gonna return price. Cool, let us try it out. So so it's gonna console.log now that we're returning it. And this should give us about $25, which is the price of a Chainlink token. So let us check it out. And it's computing, it's running, and there we go, $25.29. Let's try some other address just to make sure that it works for all of them. For example, let us try Uniswap. So Uniswap has its own token called Uni, and this is worth, according to Etherscan anyway, $25.93, and too close. Let's do Aave. Aave is like a different value because it costs $304, just to make sure that the price is a little different. So let's go ahead and copy this address. Let's go back to VS Code. Let's create another variable called let address Aave, and it's just equal to the value that we just copied from Etherscan. And let's go Aave. Now let's try to run this, and hopefully the value is gonna be correct. So the value is gonna be $304. Perfect. So it actually works for all of them. Okay, great. So this is this method is actually also V2. So get USD V2, right? Because it gets it from V2. Now let me show you how to get the price from V3. It's a little bit different, and you'll need to know it if you wanna scour V3 as well as V2 for your tokens, because V3 is much newer and much more sophisticated. So let's create a new method called get price ETH V3. And it's gonna be an async function as well, and it's gonna take the address, of course, string. So now it's gonna be very similar in the beginning, so we can even, but I'm just gonna write it again from scratch. So it's gonna be very similar in the beginning. So first of all, we'll need the factory, right? So let Uniswap V3 factory, and that is gonna be equal to web3.eth. Just don't forget new web3.eth.contract. And it's gonna take Uniswap V3 factory ABI, and it's gonna take Uniswap V3 factory address. So let us get these values the same way we got them for V2. So let's just go to Google and let's type Uniswap V3 factory. Here we go. It's actually on Etherscan. This Uniswap V3 factory. Yep. It's a verified contract, just so I can make sure it's not a scam. I mean, it's not like we can get scammed doing what we're doing, but just to make sure it's the right contract. Yeah, this is a lot more sophisticated. As you can see, there's a lot more code, a lot more files. But if you scroll all the way down, eventually we will find the ABI there somewhere. Like that. just fell off. All right, here we are. Here's the contract API. Let's go ahead and copy this to clipboard and create a new file as we did before. And this file is going to be Uniswap V3 factory API.json. There it is. Just go ahead and paste everything that we just copied from Etherscan right here, save it, let's close it. And here in index, we'll just go ahead and so let Uniswap, might as well use const, Uniswap V3 factory API, and this is equal to json.parse brackets fs.read file sync Uniswap, yep, Uniswap V3 factory API.json. So here is our Uniswap V3 factory API, and now we of course need the address, const Uniswap V3 factory address, and this is equal to simply the address, which we can get from the top of this page right here. There we go. And now that we have this and we have the contract, let's get the pool from V3 instead of V2. So to get the pool from V3, we just go let pool, and it's equal to Uniswap V3 factory, which is the contract dot methods dot, and it's called get pool in our case. In the V2 it was called get pair. In the V3 it's called get pool. It takes 3 arguments. This one. First arguments of token 1, second argument of token 2, which is VETH, which we don't have yet, but we'll get it. And the third argument is the type of the pool. And the type of the pool means how much, basically the difference between the commission that is paid towards the liquidity providers per transaction. So there are 3 types of pools. There are the ones that pay 0.3% and it's represented as 3,000. There's a type that pays 0.5% and it's represented as 5,000. And there's a type that pays 1% and it's represented as 10,000. So the one that pays 0.3% is by far the most popular pool in the Uniswap V3 world. So we are gonna use that for our reference, but we could use any of them and we can get the price. So we're gonna use 3,000 for this value. I'm just gonna leave a comment here, 0.3%. So liquidity providers, yeah, you got the idea. So let's get address of wrapped ether. It's right here. I'm just gonna copy that from our previous function and paste it into here. Yep. Let's paste it right here. Now we have the pool. As I like to do, let's just go ahead and check that we actually do have the pool and nothing went wrong. Console.log pool. Okay, cool. And now we're just gonna go ahead and call the function eth v3 with the address of Aave. So let's go ahead and call this npm run dev. Right, I don't think we called it. We just did the get pool. So dot call. There we go. Right, we didn't await it, so we need to await. There we go. Okay, cool. Now we should. There we go. There's our address. It's actually pretty fast. Let's go to Etherscan and paste this address into the bar. And here we have a Uniswap V3 Aave. So we got the right pool. And here are our values: 13,000 Aave tokens and 273 Ether. And if we were to do the same calculation for V2 for this particular pool, we wouldn't get this. We wouldn't get the right answer. So if we were to divide this by that, we wouldn't actually get anywhere near the right answer. And the reason is because there isn't just the one pool. There are actually 3 different pools of Aave with wrapped ether with the 3 different commission schemes. So what we need to do is we need to get all 3 of those pools and get an aggregate. So get an aggregate of all of the balances and then divide it by 3 to get the average, and then we'll get the price. And even then, it's only gonna be like approximately right. It's not gonna be exactly right. So in order to get the price exactly right, Uniswap V3 actually stores the price in the pool as a square root of the price shifted by 96. And what that means is, I'll show you in a second. Basically, once we have the pool, we'll need to create the contract of the pool. So in order to create the contract of the pool itself, what we'll need to do is just go pool contract and equal to new web3.eth.contract as usual, and it will take Uniswap V3 pool API and the address, of course, and the address is going to be pool. So what we need is Uniswap V3 pool API. Let's quickly source it from Google. Actually, we are right here. This is a Uniswap V3 pool. So all we would need to do is just go contract, scroll all the way down to wherever the API is, and just copy this. So let's go ahead and create a new file. Uniswap V3 pool API.json. Right here, and paste. Yep, save, and we'll just basically quickly create it. You might even do it right here, just to keep consistent. Uniswap V3 pool API, and that equal to json.parse fs dot what's it called, read file sync, and Uniswap V3 pool API.json. There we go. So now that we have this value and the pool, now we have the pool contract, and from the pool contract we need to get the value called n. So I'm just call it n because it doesn't really have a name, but what this value has is some interesting variables or attributes of the pool contract that we'll need, and one of them is going to be the square root of the price shifted by 96, and I'll show you what that means. So let's go ahead and get the value, the n value from the pool. So it's going to be await and pool contract dot methods dot it's called slot 0 dot call. Okay, and let's just print n just to so we can get a visual of what it actually has. npm run dev. Cool, here we are. This is the n, and as you can see, n has a bunch of stuff like a tick, observation index, and all of the things mean something, and you can find them on Uniswap docs. But what we're really interested in is this particular value, square root price shifted by 96. This value right here is the one we're after. And the way we would use this value is basically, so the actual price of a token would be as follows. I'll show you. So it would be square root price shifted by 96 to the power, taken to the power of 2. And this would be, this whole thing would be divided by 96, 10 to the power of this whole, no, not 10 to the power of, I believe it was 2 to the power of 96, and 96 itself is times 2, so to the power of 96 times 2 to the power of 192. So this is the actual formula, and then this whole thing again is going to be divided by the difference between the decimals of the token 2 and token 1, which means that token 2 is our wrapped ether, so that's going to be 18, and token 1, whatever those decimals are, so this is going to be divided by 10 to the power of, and 10 to the power of difference between, so difference between so basically token decimal 1 and token decimal 2, so minus token decimal 2. So if they have the same decimal, for example Chainlink and Ether, they both have decimal that is over 18, so it's going to be 10 to the power of 18 minus 18, so 10 to the power of 0, it's going to be 0, makes no difference. But if the decimal is indeed different, it's going to make a difference. So this is the actual formula to get the price, and all that is sourced from this little value that the pool itself stores. So let's go ahead and calculate the actual price. So let price is equal to Actually, first let's define the square root 96 value. So let square root price 96. Let's go probably port 96. That just means shifted by 96, and that equal to n dot square root price x 96. I believe that's what it's called exactly. Yep, square root price x 96 by 96. And now that we have this value, let price that is equals to so square root. I just call math.pow because it's going to be square root. So square root of price and 96, and the second value is going to be 2 because it's going to be to the power of 2. And this whole thing is going to be divided by math.pow, and it's going to be 2 to the power of 192, right? I don't think we need parentheses, but I'm just going to use them to be safe. It's going to be divided by this. And then again, this entire thing is going to be divided by math.pow. So it's going to be 10 to the power of the difference between the decimals. So parentheses, token decimal is the first one, and the second one is going to be 18 because we know that the decimals of wrapped ether is always 18. So let's get the decimal of a token first. So let token decimal is equal to await token contract dot methods dot decimals dot call. And of course we don't have the token contract because we've never defined it, so let's go ahead and define it up here. Const token contract, and that is equal to new web3.eth.contract that takes token API and address. Because we don't have the token API, so let's go ahead and make it const token API that is equal to just basically copy this entire right hand side of the file, right hand side of the line, and instead of looking at Uniswap V3 pool API, we're just going to go token API. Cool. Now that we have this value, we have token decimal, don't we? It's right here. There's token decimal. Did I misspell it or something? Left side is unused. Oh yeah, right. So math.pow 10, it should be minus. I did a comma for some reason instead of minus. Cool. So that should give us the price, and then we just go ahead and console.log price. Now let us see if we actually get the price. Cool. The price is 0.09. So what's the undefined thing? All right, this, because it doesn't return anything just yet. But in any case, the price is 0.09, which means that it takes 0.0969 ether in order to buy one Aave token. Now let us go ahead paste this value into Google and times that by the known price of ether, which is 3156. 3156. And I guess it's 305, which as we know is the known price of Aave, $305. So it actually works, and it works great, and it's accurate. So let's go ahead and return this price instead of console logging it. Return price. So now we might want this price in USD as well. So USD instead of just in ether. So let's go ahead and create another function, and we'll call it get price USD, and that's going to be V3. It's going to be an async function as before, and it takes an argument called address of type string, and basically it's going to be pretty much the same thing as we did before. So let price ETH, and it's going to be await, and we're going to await get price ETH V3, and then let price, oh yeah, of course, and this is gonna take address USDC because we need the price of that, right? So the address of USDC was up here. We've already defined it somewhere, right? Here. I'm just gonna copy this and paste it into here. So address USDC is equal to that. So here we go, price ETH. And then of course price ETH is equal to 1 divided by price ETH, because we need to know the actual price of Ether in US dollars, not the price of $1 in Ether. I think I misspelled that. Yep, ETH. And then now that we know the price of Ether, we're just gonna go ahead and say let price token, and that's just equal to wait get price ETH V3 of the actual address that we're interested in, and then let price, and that's just equal to price of token times price of ETH, and we just return price. So a very simple function, and let us see if it actually works. So let's go ahead and say price USD V3. Okay, let's see. Should be $305 if it worked correctly. Oh, that's not $305. That's 3.055 something. That is very not right. So let's see. Oh yeah, right, I know. Because basically when we get the price of USDC, right, what we didn't do as we did for Uniswap V3, right? Remember how we also had it divided by the difference between the decimals? Yeah, we did that in Uniswap V3, but for some reason, right, token decimal, method of decimals. So let's go ahead and debug it real quick. So let's see if we actually have the price of the price of USDC correct. So console. So we'll just go ahead and do console.log price of ETH, right? So step by step, we're gonna console.log that and see if it's correct. Right, 3.15. It is clearly not correct. So the not correctness begins with the price of USDC. So what we're trying to do is we're trying to get price of ETH V3 with the address USDC. So let us debug this. So first of all, what it does is it's creating a pool, and it's getting the address and token and the address of ETH and 3000. So in this case, it should give us the Uniswap V3 pool between USDC and wrapped Ether. Then it creates the pool contract, which is also V3 pool. Then it gets the n, and it gets the price in square root x. Then it gets token decimal, which should be 6, right, in this case. So let's go console.log token decimal just to make sure it's 6 in our case. At least one time it's going to be 6, because the decimal of USDC is 6. Yep, it's 6. Of course, it's going to be 18 afterwards, so it is 6. And then price is equal to so to the power of 2 divided by 2 to the power of 192 divided by, and this whole thing is divided by 10 to the power of token decimal minus 18. So it should have been divided by 10 to the power of 12, 18 minus 6. So let us just dissect it a little bit. So let price is equal to math.pow, which is square 9 times 96 to the power of 2. Comment this out. And this whole thing is going to be divided by math.pow 2 to the power of 192. Right? Cool. So this seems to then price is simply equal to price divided by, well, let's just console.log price in this case, and we'll just make sure that this price is coming from here by prefixing it with some silly string, and then go price, and then try to see what that value will be. Okay, 3.5. Okay, so instead of doing the dividing, let us try times. So price is equal to price times, and then 10 to the power of, so math.power, 10 to the power of 18 minus token decimal. Oh, that's where I went wrong. I see. It's not it wasn't token decimal minus 18, it was 18 minus token decimal. So let's just divide this instead of times, because I believe it's divide. And let's console.log price. So I'm gonna control X this, control V it here. Okay, let's try. Okay, that actually gets us the correct value. So that's what I'm wrong. We can just so we can just get rid of that. And we can uncomment the original price, and instead of doing it token decimal minus 18, it's 18 minus token decimal. Okay, let's run that again. And as we can see, it actually gets us the correct price now, 305. So let's get rid of all of the debugging purposes console logs. So get rid of that. Get rid of this, we don't need it anymore. Get rid of all of that, because our original one actually works now. And now the price above it on its own is just gonna be 305. So yeah, as you can see, 304 now. Price went down a little bit. So as you can see, it actually works, and this is how you get the price from Uniswap V3, given that there are many different pools for the same token pair. Okay, so now that we have all these methods and they're working, the next step is to actually change all of this in order to allow us to query this program using GraphQL from the front end. So we'll need to create a few folders in order to organize our code a little bit better. Let's go ahead and create a folder. Let's just stop running the code. So inside of the root folder, let's go ahead and create a folder called functions. And in here, we'll create a file called ethfunctions.ts. There we go. Now we have a folder called functions. Actually, we didn't need it in there. We needed it within the source folder. So let's go ahead and delete that folder. There we go, that's all gone. Cd src source and create it here. Functions, and then touch ethfunctions.ts. Just our functions are in a separate folder. So let's go ahead and copy all of the functions that we just made. Here they all are, all the way to the top, including the get block number. Control C. It's gonna go to Control C for now, and then eventually I'll just delete them also. Control V, eth functions. Wait, just Control Z for a second. This is eth functions, right? Yeah, Control Z. Get rid of it all. And let's go ahead and say const eth functions equal to, like that. It's a functional component, and inside of this I'm just gonna paste all of the stuff, all of the functions, and then at the very end, after the last function, I'm gonna go return, and I'm gonna make all of the functions, export all of the functions to make them available outside of this functional component. So get block number will equal to get block number. It's a bit of a tedious process, but eventually it's gonna, so get token name is get token name. So what this does is basically it exports all of these functions so that we can use them outside of this component, such as an index, and we can do it functions dot, for example, get token name, and we'll be able to actually call this function and run its and get its value, get its return value. So get token symbol is get token symbol. There we go. Get price on ETH2 is get price ETH2, and get price ETH3 is get price ETH3. Thank God for autocomplete, right? Get price USD V2 is get price USD V2, and get price USD V3 is get price USD V3. That took me about a minute, but and the one thing it should take is Web3, because it's gonna use this Web3 here for all the things. By the way, let's export it. Export const. I'm not sure how is it that it's not complaining that it doesn't know what V3 is. I'm sure it will in a second. Let's go back to here. Let's actually delete all of these functions from here now, because we no longer need them within the index. And let's go ahead, let's go to main, and instead of having it like that, let's go ahead and say eth functions is equal to eth functions, like that. I can't find eth functions. I mean eth, yeah, I mean eth functions. Yeah, let eth functions, and then instead of awaiting get USD V3 like that, we're gonna say eth functions dot get USD V3. And as you can see, there we are. It's finally complaining about not knowing what Web3 is. So it's gonna take Web3 as an argument, which means that it will, and of course it means any TypeScript, and we're gonna pass Web3 to eth functions. Web3 is defined over here. And let's go ahead and let's run our program and see if it gives us the same result. Okay, it doesn't. So what's wrong with it? Oh yeah, I see. It's all of those imports. It's all of those imports. You know how you import this stuff. So for example, so let's go ahead and basically move all of those API. We can there are two ways you can do this. We can either move all of the API files into the functions. That will be the easy way, or we can move them into our own separate folder and basically just change the import in order to find it properly. So one thing it doesn't have is a fez. So let's go ahead and import this. Control C. Just go ahead and go do that. Control V. Now it has that import. It's still gonna be wrong though. So what we're gonna do is we're gonna create a new folder. And in this folder, what we're gonna do is so let's create a new folder called ABIs, or just ABI. And we're gonna move all of our ABIs. So we're gonna move token ABI JSON. Yep, move. We're gonna move the Uniswap V2 JSON file. We're gonna move the V3, and we are going to move the pool also. So all of the JSON ABI files we have just moved into the ABI folder, and functions has the eth functions. Wait a second, eth functions should be within functions. So let's go ahead and move it as well. I didn't create it in the correct folder. Yes, update imports. Okay, cool. So now within eth functions, what we have is here, and this is not gonna work. It should be /ABI/token ABI JSON, but even that's not gonna work because fs is not a relative import in JavaScript. So what we need to do is we need to do const path is equal to require, and then what we're requiring is path, because we'll need the path of our current directory. And then once we have the path, we just do inside of the read file sync, what we're gonna do is path.resolve, and then it's gonna be dir name, like that, which is our current directory, like when you type pwd into the terminal, comma, and then it's just gonna be all of this rest of the stuff, and then just one more bracket, one more brace to complete it, and I believe that is gonna work. So we just basically need to do the same thing for all of the other ones. So for the token API, just copy this, and then each one that has a token API, let's go ahead and paste it. It's not very well done, by the way, because as we can see, I have to change so many things, so many different lines of code for exactly the same thing. So a better way of doing it would have, of course, been just taking them out and having them in a separate constructor function, and then we could have just changed one line, and that would have changed it for all of them. But instead, we have to do it this way because I didn't exactly do it in the best way possible. But I'm not gonna change it now. I'm just going to real quick manually change all of them. So anywhere else that we need token API, yep, right here, token API. And within this function, we also need to change, in addition to token API, we will need to change Uniswap V3 factory API. So it's going to be ./API/ and it's going to be path.resolve and your name, and of course the actual address, and one more closing parenthesis. And same thing right here. So path.resolve, your name, that, and one more closing parenthesis, and it's going to be ./API/ Uniswap API. So that's all of them for here. This is for V3, and the one for V2 didn't have any. Oh, it did right here. So let's just change that. Path.resolve, your name, and the actual address, one more closing parenthesis, and then ./API/ this. Cool, I believe that is all of them. And if it's not all of them, we'll just get an error and we'll know exactly where another one is in order to change. So now that that is done, let us run our program. npm, let's get out of the source, and npm run dev. Let us see what's gonna happen. What are we actually running? It functions, but yeah. So technically speaking, yeah, there we go, 303. It actually worked. So now that we have it better organized, meaning that API is in its own separate folder and functions are in its own separate folder, let's go ahead and change our whole program in order to make it basically let's make a program, run a server, and that server is going to be GraphQL, and we're going to be able to use as GraphQL queries in order to query all of these functions from outside of this program. So for example, on a front end or just in a playground, on the GraphQL playground. So in order to do that, we'll need to create a few more folders. So inside of source, so cd src, we're gonna create two folders. Actually, two folders or one folder? Let's create one folder for now. So make dir, it's gonna call resolvers, and then we're gonna create a folder, not a folder, but just a file, attach, and it's gonna be schema.graphql, like that, schema.graphql. By the way, what's wrong with tsconfig? I have no idea why it's red and why that is so, but users on desktop src/eth function.ts is not found. The file is in the program because match is associated ts. Okay, I have no idea, but as long as it works, we don't give a damn about that. So just, yeah, it still works. In any case, so now that we have those two folders inside of resolvers, so what we're gonna do is make a new file. We're gonna call it resolvers.ts, and inside of schema.graphql, we're just gonna make the actual GraphQL schema. We don't need that, so let's go ahead and close this for now. Yep, let's stop running this, and let's go ahead and let's create our GraphQL schema. All right, let's start working on the GraphQL schema. So schema is basically just the definitions of the types of queries that we're going to run. So the way we do that is just go type query like this, and then we're just going to get all of the possible queries that we would want to invoke from our front end. So one of them would be, for example, get token name, and this would take an argument. An argument is the argument is address, and it's of type string, and its return value is a type string. So that's one query, and then just keep going and get them all one by one. So token symbol, This also takes address of type string, and its return value is a string, right? And then we can get total supply, and its address is it takes an address of type string, and it returns a value, and normally that value would be an int, but let's give it a string because in case that int surpasses the 32 bits, or was it 64 bits, I don't remember exactly which, JavaScript is gonna crash. But if it's a string, then nothing's gonna happen. So we just always, to be on the safe side, return all of the return values as strings, and then they can just convert them to int or float or whatever is their need. Let me just plug in my laptop charger because it's advising me that the battery is low. I'm just gonna plug it in and we'll continue. Bear with me for a moment. There we go. Perfect. Let's continue. So get what else do we have? Get price of it from V2. And then that's gonna take an address of string, and it's gonna return string also. Remember, any value that is we're returning everything as a string, so just copy that and do the same thing for 3, and then get price USD V2, address of type string, and that's returning a string, and then do the same thing for V3. Control C, Control V, and that's V3 also. Okay, this is all we needed to do for our schema. Now let's go to resolvers. Now resolvers is just an object, so we go export const resolvers like that, and this will have a type. So this object will have an argument called query. So query would just go like this, and it's gonna be, all of these are gonna be the methods that we're gonna be calling from our front end. So inside of here, we're just gonna have, for example, one of the queries will be get token name, and this is gonna be an async, and we'll take just no arguments like this for the first one, and it's any. And then the second one is gonna be address, right? And then it is going to gonna open some curly braces after the so it's a function, it's an arrow function. Gonna open curly braces, and then the reason this is highlighted as red is because we've never used the address yet, so we're gonna use it. So for example, if we do a return address, now address, and let's make it any. Clever's value never read. What if we made a string? Okay, cool. We'll just keep it as address, simply as is. And then in here, what we're gonna do is we're gonna call the eth function that is responsible for the token name. So for example, it's called get token name from eth function, and then we're just gonna call that and return the relevant value that is returned. So we're gonna do it like this. Outside of all of the queries, we're just gonna go ahead and we're gonna say eth functions is equal to eth functions, like that. That's been imported now. It takes one argument, which is web3, and we don't have web3 here, so we're just gonna have to copy and paste all of this web3 stuff into resolvers as well. There we go. So now it has web3, and also eth functions shouldn't be inside of the query, it should be outside of the query, so like that. It's gonna be let eth functions is equal to that, then get token name, takes an address of, yep, and then it's going to return the value. So let token name as before, that's equal to wait eth functions dot get token name of address, and then we're just going to return token name. And that is all that we had to do in order to get the token name and expose it as a GraphQL query. Okay, the reason why this was playing up was because address has an implicit any type, and there's nothing I can do here to set its type in the GraphQL. So basically what I'll need in the resolvers. So what I'll need to do is I'll need to go to tsconfig, which is right here, tsconfig.json, and basically change, set a no implicit any and set it to false, like that. And this will solve our problem. So now the compiler no longer cares that this the address has an any type, and we are all good and it works in this sense. Okay, so now that we have eth function to get token name, we'll just basically return token name, and that's all we need to do for get token name. And let's do it for the rest of them. So comma, and then the next one, get token symbol. It's also going to be an async, and same exact thing. I should have actually just copied and pasted it, but I'll do it for the next one. Takes address, and then it's an arrow function as well. Okay, let token symbol is equal to wait eth functions dot get token symbol of address, and then return token symbol. Cool. Let's just copy this entire thing and paste it. Don't forget the comma. Okay, let's get total supply. Now total supply is gonna be just that, total, and inside of here is gonna be, we're gonna be calling get total supply. And it's going to return total supply dot to string, because remember we want to return it as a string, not as an int. Get total supply seems to not exist on eth functions, so let us go ahead and double check. Get total supply, did I misspell it, or did I just simply not add it? I didn't add it. Cool. Get total supply is just equal to get total supply. Cool. That should solve the problem. Yep, it did. We all good. Now let's go on to the next one and just copy and paste. The next one is price eth v2, and pretty much the same thing. We just go ahead and we go price, and that is equal to price eth v2, and then we'll just return price dot to string again. Same exact thing for price v3. Okay, that's also not exported. Let us go ahead. Oh wait, actually, what's wrong with this? Oh, no comma. There we go, all solved, and we just go price v3, and then returning price to string. Now next, USD v2, comma, USD v2, and we're just calling it USD v2, and we're returning price to string. Let's just copy that, don't forget the comma, and then USD v3, the same exact thing, USD v3. So this is our resolver, and this is our resolver all done. So this is the query. All right, so let's go back to index and let's create a function here. So let's create a function called start server. It's gonna be an async function, and within this function we're gonna start the Apollo server in order to actually query our resolvers, our schema through GraphQL. So in order to start the Apollo server, you need to install a few dependencies. So to install the things we need is npm. First of all, we need Apollo server, Express, because we're gonna use Express for the actual server and Apollo as like a wrapper. Then we will need Express itself by itself, and we will need GraphQL, of course, and we'll need something called GraphQL import. So let's install these 4 dependencies real quick. Forgot to write install. There we go. Let's install these 4 dependencies, and once they are installed, we can proceed to starting and launching the Apollo server. Cool, there we go, that's all done. So now what we can do is we can basically create express app, const app equals express, like that. And express should be imported as well. Couldn't find name express, so let's go ahead and import express. Import all as express from express. Cool. Then let's do type defs. So type definitions, and that's basically your schema. It's just called type defs in the official Apollo language. It's basically your GraphQL schema, because these are the type definitions. So type defs, and that's equal to, by the way, we'll need path as well. But yeah, so type defs is equal to import schema right here. And as you can see, it's automatically imported from GraphQL import schema. And inside of here, we'll need path dot join, because we'll need our current path. And then inside of here, we'll got your name and the direction of our schema, the GraphQL, which is just not at GraphQL. Yep, that's all done. And then after this, we'll just start the actual Apollo server. So const server, and that's equal to new Apollo server. Let's press enter in autocomplete, and it will automatically import it for you. If you don't have this kinds of autocomplete, as you can see up top, it's auto importing it. So just go ahead and copy this line number 5 in order to import Apollo server from Apollo server express. And this takes 2 arguments. This takes the type definitions, type defs, and it takes the, what else does it take? Type defs and the resolvers. So click resolvers, and that's also imported now from our resolvers. Or not, it didn't import automatically, yeah. So what is wrong with this? Expected 1 argument but got 2. Const resolvers. All right, the resolvers itself doesn't take any arguments, yeah? No, it does not. Okay, expected 1 argument but got 2 in const resolvers. Right, so Apollo server, it actually takes an object as an argument. So this is why it was playing up, because it only expects 1 argument, and that is an object, and the object contains 2 things. So it contains the type defs and resolvers. So basically we'll just need to do it like this, and then it works. So once that is done and we have the server, now we can go ahead and start the server. So await server.start, like this, and then we go app.listen, and we're going to be listening on port. So we're gonna provide the argument for port, and it's gonna be 4000, and then we're going to make it as a callback function, like this. And we're just gonna go ahead and say console.log, and we'll say server ready on, and we'll just print out the port. Actually, not like that. Server ready on, and it's gonna be localhost, and it's gonna be port 4000 / and we'll just go ahead and say server.GraphQL path. Oh yeah, close the bracket. There we go. And I believe that is it for starting the server. Then we'll just, all we need to do is just go ahead and actually start the server. So let's comment this out, and instead let's just start the server. So let's go ahead and say wait start server, like that, in the main method, and then we just call the main, and let's see if this works. npm run dev. Alright, great. So it seems to not have crashed, and the server has started on localhost 4000 / GraphQL. Why is it -- GraphQL? Alright, because I need to get rid of this slash. Okay, cool. But in any case, we get the idea. So let's go ahead and go to the server. So localhost 4000 / GraphQL. Okay, localhost 4000 / GraphQL. Okay, let us debug this real quick, see what is wrong with it. Right, so we just forgot to apply the actual middleware. So as you can see, we're declaring the app, which is just Express, but we're not actually binding the Express to the Apollo server. So it'll just be server before we start the server, right? So server.apply middleware, and this takes one argument, which is app, and then we start the server. So let us see if this makes any difference. So crashes. Okay, cool. New error. Apollo server TS595. You must wait server to start before calling server.apply middleware. Okay, cool. Well, at least that error was very informative. So server apply middleware is actually after the server, not before. Cool. Let us run it again. Yeah, it actually works. Now let's go to the localhost 4000 / GraphQL. Yay, good. So just press query your server, and this is your GraphQL playground as generously provided by Apollo. So let's go ahead and say query, not example query, let's go get token name, and inside of here this takes one argument, which is address, and this is of type string, and then we call the actual query. So get token name, so address is equal to address, and then it'll basically give us the response. Now inside of the variables is basically like as follows. So address, and it's gonna be, let's say it's Aave, right? Not Uniswap Aave, but just some random token. Let's do Aave. Oopsie. Let's search something. There we go. Let's go ahead and copy the address of the contract and paste it in here. Expected JSON object. Okay, so I'm guessing that's not how you do it. Let me just quickly double check on how you do the variables. Variables on GraphQL Playground. Apollo. Okay, so where's the variables? Here, right, it's supposed to be like this. So query, and it should be inside of the curly braces as though it was a JSON file, and both of them are encased in brackets, in quotes. So where is our yep, so it's gonna be like this, and it's gonna be address like that, and that is equal to this, and then let's close the curly brace. Cool. So this is our argument. Address is equal to the address of Aave, and let's run this and see if it works. Great, it actually works, and it says Aave token. So let's go ahead and create another query. Query get token symbol, and same thing, address of type string, should have a comma. I'm not sure. I'm not gonna give a comma just for the moment. and then get token symbol, and it takes address, which is address. Right, cool. Let's run this. Yep, it works. So let's get the price. Let's get the price from V3. Get price V3 ETH, and of course it takes address also of type string, and then get price. You can actually see it auto completed for me. So let's get price ETH V3, and in here we'll just do address, which is equal to address. Let's go ahead and let's run this. It's gonna take a little bit longer, but it will get us our price. As you can see, 0.09, which is about right. So let's go ahead and query get price V3 USD. Or was it USD V3? Yep, USD, and that's address of type string, and then get price USD V3. So it's actually USD V3, not V3 USD. USD V3, and then address. Let's go ahead and run this, and should be 300 and a bit. Yep, 302, perfect. It actually works. So if you had more arguments, you would just insert them here with a comma. So it would be you just go comma and type something else, and so on, as though it was a regular JSON file. And if you had more queries, you would just type them here, and then you can query them one by one like this, and you actually have the docs here. For example, you can see, like, you can click here and it tells you what arguments it takes, and yeah, that's it. It takes you what arguments it takes, and all of this you can actually implement on the front end using something like React or whatever else, any other front end framework or language that you choose, and then you could implement this GraphQL server on the front end using these queries as they're written here. And I'm gonna show you how to do that in the next video. So just to recap, what have we done? So we've actually connected to Alchemy. So we've connected to Alchemy, as you can see here, and what that means is that we've connected to Alchemy and then to the Ethereum node that Alchemy runs, and they run a full archive node on Alchemy. So we're actually pulling all of this information from the blockchain itself, from the node. If we were to run a node on our local machine on our computer, then we wouldn't need to use Alchemy. We would just basically instead of this URI, we would just do a local host, and on the port of wherever our node runs, and then instead of having this Web3 being imported from Alchemy Web3, as you can see, as we've done, we will just import it from just regular Web3, the npm package, and then we would be able to query all of the data from our local machine if we were to run the node on the local machine. But I am not running the node on my machine at the moment, so I'm using Alchemy for simplicity's sake, which is a really good service. Yep, so we've defined Web3 by connecting to the Ethereum blockchain node running on Alchemy. Then we've started our Apollo server, which actually exposes all of the functions that we've written to a GraphQL kinds of API. So we're able to query it using GraphQL, and then so all of the functions we've actually imported them here, and they all exist within the resolvers. As you remember, from resolvers we actually have all of these functions, and they just call it functions, and whatever the function name is that we are interested in at the moment for the query. It functions is where all of our functions logic actually lives. So we have get block number, we have get token name, and all of our functions actually live here. For example, this is the price and stuff like that. And yeah, and then the ABIs live here, and they're just JSON files that we import wherever we need to import them. And then the schema just basically gives the names to the queries that we would then use from the front end or from the playground, as you've seen. So these names should match the schema names exactly, and also the schema names should also match the names that we give in the resolver. So this should be exactly the same as that. And if it's not, then the compiler is just gonna throw you an error. Yeah. And that's been that. A very simple program to query the Ethereum blockchain. All right, cool. So what we've just done is we've created a backend server, and on that server we've connected to an Ethereum node, and we've queried that node for relevant information, and then we've made that information available through a GraphQL API. In a future video, I'm going to use React to show you how to create a frontend in order to create a pretty simple block explorer, something akin to Etherscan, where you could just type an address or a name of any token and get relevant information on that token, such as the token name, the total supply, the price, and so on. This was Remy. It's been a lot of fun, and as always, I'll see you in the next one.